Hi friends, this is Sai from Department of Civil Engineering. So in the last class we are discussing remote sensing and GIS applications. So once again I am reminding you define and explain of remote sensing. So let me first of all discuss about remote sensing. So remote sensing is the science and art of achieving the complete information of a particular object or area of data analysis obtained by the device that does not come in a contact with the object or area that is investigated. So here the remote sensing gives itself the definition. So the art of an object, art of achieving complete information. So we must have complete information about the image analysis. So you have to study the here image analysis. So main remote sensing is mostly used here at engineering maths, at irrigation departments, next at military levels. Uh, all over here remote sensing are used here. So without any physical contact. So you do not have any contact with the object. You are studying about the area or an object. So in this section let me discuss about the basic concept of remote sensing. So remote sensing is a technology used for the identification and understanding the particular object of the conditions of an environment through the queries. So can be explained by considering a computer monitor. The concept can be explained by considering only computer monitor. When a person views the screen of a computer monitor, he is actively engaged in remote sensing. So you all people know, last we have discussed about the any signals. So signals are controlled by a computer by screening. They will give red signal, green signal or yellow signal. So that symbols have been given for some options. So red for do not come or stop here, green go no problem here, orange ready to stop or ready to glow. So some symbolics are given in remote sensing. So it will be operating by only the computer monitor who are operating here. So the concept by how it gets the data. So when light is radiated from the sensor passes or over specified distance and remote to some extension it encounters and is captured by the human eye. Then the individual eye sends a signal to a processor where the data has been recorded in the information interpreted by recognizing the different types of signals. So here different types of signals are we try to understand the what is happening here and there. So for example, loco pilot. Loco pilot means train driver. So he knows up to some distance he eye can visible. So his communication with the eye contact, he passes every signal with the clarity with the help of the remote sensing subject only. So at the same time he had a communication. He calls to the local station masters. So at the gates all are closed or open, automatically gates will be while train is passing. You all see the gates are being locked. So a train is coming, gates has been locked, signal is given. If any sudden problems arise, so it will be intimated to the driver. Loco pilot can understand the situations, so he can handle the train to stop, to move or to handle it. So it is happening only by the remote sensing only. So by recognizing different types of signals. So there in railway station they are using three signals. So like otherwise you see the airport. So airport also in night time airports functions with the help of the lights only. So there will be several signals. So down it's have to runway at runway they will arrange around the runway there will keep signals, red signals. In the runway they will keep the white signals. So in some way there will be keeping green signals so that the the pilot can understand what is the situation runway to how to we have to monitor it. So in that also in each and everywhere subject remote sensing is a subject is using day by day. So it is a technology subject. you all must have a basic kind of idea of the remote sensing. So basic idea means here simply the study of the art and science achieving the combination of a picture analysis. So you must have ability of the art, so you must have to design it well good. So you must have to study the picture so you can understand the picture. So you are facing many problems at irrigations department. So irrigation department means it is used for crop cultivation. So in summer the crop will be drained, so the land will be seen be clear. So in a rainy season the crops are will be plotting, seeds are there, so small greenery you can see. So by before cutting the crop, so you see full crop. So you see here three pictures. In three pictures you will be identifying different modifications. So we all discuss, so this is simple concept. The concept is to understand the picture, to you have to study, you must analyze. As a civil engineer you must have a basic concept of it. So next to basic concept of remote sensing, so let me discuss on electromagnetic radiation and electromagnetic spectrum. So electromagnetic spectrum you all studied it at lower classes. So the electromagnetic spectrum, electromagnetic spectrum. So electromagnetic spectrum is defined as ordering. So it is defined as an ordering of a radiation based upon the wavelength, frequency or energy. So the complete array of electromagnetic waves involving the electromagnetic spectrum, which is the continuum of energy from wavelength ranging from meters, nanometers and traveling with the speed of light. So the electromagnetic spectrum propagates through the vacuum such as a outer space. The electromagnetic range is shorter wavelengths comparing to the gamma and X-rays to the longer wavelengths comparing microwaves at broadcast to useful for the point. So here electromagnetic spectrum in lower classes you all study. So light will be passed in the straight line. So light passing, so perpendicularly electrical is generating. So where you have generated electrical, so in the path of the only electrical there will be a perpendicular magnetic induction around it is being developed here. So with some wavelengths and frequency, so it has electromagnetic spectrum has been developed here. Electromagnetic radiation is energy emitted or reflected from the features of the ground transmitted of the waves of this sensing instrument. These electromagnetic waves energy transported through a space in the from periodical distributions of the electrical and magnetic field. So these waves are travel from speed of light. The frequency and wavelength of electromagnetic waves are based upon their sources. The wide range of the frequency encountered, which also includes the electromagnetic spectrum, wavelength is measured in meters or nanometers or micrometers or centimeters. Frequency is measured in hertz. So we are having some region. So electromagnetic radiations have some radiation. So let me discuss it one by one. Gamma rays as less than 0.03 micrometers, X-rays 0.03 to 0.3 micrometers, UV rays 0.3 to 0.4, visible region 0.4 to 0.7, IR region 0.7 to 1, infrared IR band 0.7 to 3, thermal IR band 3 to 5, radar 0.1 to 30 centimeters, radio waves greater than 30 centimeters. So with the help of these radiations, so they can take the pictures of the clarity. So so next one is electromagnetic is a small topic here. Electromagnetic spectrum you all studied at lower classes only. So let's move upon to the next one, sensors. So sensors, so sensors are the very important topic in this. So the sensors are the remote sensing instruments that are designed for the measuring of the photons, the charged plates made up on the light sensitive material. acts as a detectors in sensors. So for example, any detecting material is there, so it will be detected by the sensors only. So there will be kept coding and decoding in the sensors. These sensors emitted electrons which they are exposed to the beam of the photons. When the magnitude of the electrical current produced increases, the then the intensity of a light increase in the electromagnetic radiation signals for the sensors to the ground station. These sensors are also recorded reflected EMR from the surface of the earth. These sensors are also used to converting radiations into electrical signals. So the sensors will convert the radiations into electrical signals, which are helpful for us at any way. So sensors is a which will be identifying some important one. uh, Sensors converts radiations into electrical signals. So for example, you see the radiations of the at railway stations, you see the signals main. So electrical signals is the best example there. So sensors are of so let me discuss. The sensors are of two types. One is passive and next one is active. So active and passive. So in active and passive also we are having here different types. One is scanning and non-scanning. So passive comes scanning imaging. So scanning play image of a TV, scanning camera solid scanner. So next one is non-scanning. So non-scanning, here we have a magnetic sensor and gravity meter. In active non-scanning and in non-scanning we are having microwave radiometer, microwave amplifier, laser water depth, laser distance. In scanning we are having image plane scanning, object of the plane scanner. So here we are having some is in sensors also two types. In sensors only two types. One is active and next one is passive. I have already shown the flow chart here some. So in a active sensors will work in the two types. One is non-scanning and another one is scanning images. So in active, let me discuss for example scanning. So image plane, real aperture radar object plane scanning. So in non-scanning comes from the all microwave radiometer, laser distance meter, it comes. uh, Another passive examples we discuss about TV camera. So all these things. So different parameters of sensors. So there are only four types of different parameters of the sensors. One is the spectral, next one is spectral, radiometric resolution, and next one is a temporal one. So in this also we will discuss about one by one. So first one we will discuss about the spectral resolution. So it is defined as the so it is defined as the detector of the minimum area of the ground by detector is placed on a sensor. The resolution is limited to pixel size. So the sampling distance can be used of the detecting size of the pixel, and image is referred to the higher when the resolution is small. Whereas resolution size is large, then the image is considered as a low resolution. So spectral image means spectral image means we for example uh, 250 kilometers image we want. So it will be taken with a small scale of 1 is to 25. So the picture clarity will be very low. So in this only we will be shown 250 kilometers. So there will be no resolution clarity. So large area with a small picture. So so it is defined as the detection of the minimum of the ground detector the placed on the sensor. So here only the small sensors has been used here. Next one is the spectral resolution. When the bandwidth of electromagnetic radiation of channels is utilized, then the spectral resolution remote sensing instrument can be determined. High spectral resolution is obtained, bandwidth which provides the high accurately signature for that one. So for example, it is quite opposite. So for example, you want only small parts area. So in this picture, you it's large spectral large area will be divided into small parts, and its small parts resolution only taken. But whereas it comes to spectral, it takes the large picture and it divides into the small pictures. So next one is a radiometric resolution. Radiometric resolution is defined as the minimum charge in the intensity level. It can be detected through the sensing system. The instantic radiometric sensing system is based upon the signal noise of the detector. So it will be some sounds will be coming. So with the help of the sounds, so it radiometric resolution will be works. So first one is a spectral, which is dividing large area into small image pictures. So it will be given only for the small pictures clarity, not huge areas. Second one is a spectral resolution. So it gives large area with a divided parts of high clarity with a more bandwidth and a high resolution. So next one is a radiometric resolution. It works under the simple, that is sounds. So it works under it revolution gives with the help of these sounds. So how does it works? So for example, any you see sometimes while small kids are playing with remote cars, so it works with the sounds. So when claps, car moves, when claps, car stops, so like that. So latest technology at a radiometric resolution, you see your mobile, so you will say hi, or you will say one clap, or you will say 3 2 1, picture will be taken by the camera. So it's the best example for radiometric resolution. So next one is a temporal resolution. So it is the smallest period which represent covers of the ground can be analyzed through the sensing system. The temporalism is land is usually lasted only it is 16 days. So last one is a temporary one. So it will be just small works, it will be taken and it will be recorded only for 4 to 5 days, and it works only for 16 days. So you see, in olden days computers are there. When you take in any new files, so when you take any new files, old files will be destroyed. So it is the best example for that one. So again I am explaining for you. So parameters of your sensors, parameters of sensors. So in parameters of sensors, only four types are there. First one is a spectral. So in a spectral, it will be small plotted areas are taken, because it's having only small resolution, and small resolution of the picture will be connected and it will be given high resolution. So next one is a spectral. So in the spectral we will take in the large area and it will be having the high bandwidth. So large area you will be taken at one capture. So again you will be studied with the parts. So next one is a radiometric. So with the basic principle sounds, so it will be taken pictures. So when the sound comes it will be taken. So next one is a temporary one. So in the temporal you will not have the permanent resolution here. It will be only recorded for 4 to 5 days and it works only 16 days. So next one is will so let me discuss on the differences between active sensing and passive sensing. So only sensing systems in sensors we are having, in sensors we are having only two. One is active, next one is the passive. So let me discuss one by point. So active remote sensing system generates its own energy and utilizes it illuminates a target and recording the energy with reflected. So best example for active is the sunlight. When sunlight hits the ground, and again it will be energy some storage. Next one is a passive remote sensing system, realizes on solar radiation of the emulates the target. So when solar radiation which comes hitting the body, so that one recorded here. So the microwave region of electromagnetic spectrum forms from the base operation to the active remote sensing system. So here micro region, only micro region has been considered in a active remote sensing system. In passive, the image and infra region of the electromagnetic spectrum forms the base operation of the passive remote sensing system. The wavelength of active remote sensing system is greater than 1 mm. So here the range of great M must be greater than in active sensing system. The size must be greater than 1 mm wavelengths. So the wavelengths of the passive remote sensing system between 0.4 to 10 micrometers. So next one is the next point for active is as the solar irradiance of the micro region is neglected, the system does not depend upon deflection of the solar. So here the system in active, it does not depend upon the solar, the system depends upon the solar in passive. Synthetic aperture radiator is example for active. So synthetic any materials are there, so remote sensing will be example here. Camera with no flashlight. So in a active sensing system, in passive, if for example in synthetic will be there, direct sunlight will be taken here example. In passive we take the direct camera, it will not no flashlight is the best example here. So in the next class I will be given very clarity about the active and passive once again. Up to here we will be discussed the introduction of sensors is over again. So again we in this video we have discussed basic concept of remote sensing. So sensors. So next one electromagnetic spectrum we have discussed, parameters of sensors also we have been discussed here. Thank you.